Hello guys, thank you very much for your previous comments on my previous videos. So I'm very thankful for liking, subscribing and sharing, also commenting on my previous videos. So I am trying to cover global certifications related to network security and cloud, and also trying to cover some basic concepts related to network security and cloud. So first I am covering some basic concepts in networking. So today we are going to see one of the most important concept in basics of networking, that is subnetting. Subnetting is an important concept. So I have taken an example here to make things easy. So I have taken an example from class C. So we have already seen in one of my previous videos that there are 5 classes, class A, class B, class C, D, and E. For IPv4, 0 till 127 is class A, class A, 128 till 191 is class B, 192 till 223 is class C. So apart from that, you can see class D and E, which is used in multicasting and research and development. So these are the classes which we use. So with this first octet, I will come to know that this is taken from class C. And this is the default subnet mask of class C. So now I am going to explain here in detail how to do subnetting. So what is subnetting? You are making small networks. So you take a big network and you divide that network into small networks. So this is your big network. This is like a big cake. You divide it into 4 pieces. So these are logical subnets. These are small networks. These are subnets. And you need to have a router for these subnets to communicate with each other. So they are this is logical grouping. So one of the main reasons was because IPv4 has a limited address space, 2 to the power 32. That is the address space for IPv4. Because of this, 2 important concepts were came in picture. One was NAT and one was subnetting to save these IP addresses. So I have taken class C example here. So first thing what we need to do is convert this into binary. So this is the binary conversion. So I have taken 255, 255, 2550. That's the default for class C. For class A, you have 255.0.0.0. For class B, 255.255.0.0. So for class C, 255.255.255.0. So I have taken class C subnet mask, and 255, when I break it into binary, so this is the value. How? So I just take 1, 2, 4, 8, 16, 32, 64, 128. So 1, 2, 3, 4, 5, 6, 7, 8. So when you have a series like this, so n into n minus 1 divided by 2. So that will be n is 128 into 128 minus 1 is 127 divided by 2. So that will be 2, 6 or 12, 2 4s are. So 64 plus, sorry, this will be 6 to n into n. This will be plus here, n into n plus. So 64 plus 128 gives you 2, 192. There is some doubt here. So it was going to be 1248, 1636, 128. So 128 plus 127, not divided by 2. Sorry, that's for other. That's how you calculate number of wires. So not divided by 2. So that will be n into. So the formula here is n plus n minus 1. If you have a series like this, how to calculate the total value? N plus n minus 1. So 128 plus 127 gives you 255. So that's the value here. So I'm converting all that decimal into binary. So 255, this is 255, this is 255. Now to do subnetting, these are host bits. So these are network bits, network, host. So what I do here in this class C, I am converting these zeros into ones. That is subnetting. Now, how many zeros I am converting based on your requirement? For example, I will say, get me 8 subnets. So what you will do 2 to the power something should be greater than 8. So 2 to the power 2, 4, 2 to the power 3, 6, 2 to the power 4, 16. So 16 is greater than 8. So that is how you define the requirement. So here, what I did, I converted two networks. So I'm left with 6 hosts. So these are network bits. This is a network bit, this is a network bit. So 2 network bits. And these are the host bits, 1, 2, 3, 4, 5, 6. So this is subnetting, converting host bits into network bits. So network bit is 2 and host bit is 6. Now, what is the customized subnet mask? So what you do here, you convert that into, so it will be like 1, 1, 1, 2, 3, 4, 5, 6. So 1, 2, 4, 8, 16, 32, 64, 128. So 128 plus 64 gives you 192. So that's how I got 192. Okay, so this is the first thing. So there are a lot of ways to do subnetting, but I'm going to show you the simple technique. So first you define your requirement, how many subnets you need. So here, how many subnets? So number of networks means number of subnets. So how many subnets I need? 2 to the power network bit, 2 to the power network bit. So network bit is 2 to the power 4. So that's my need. So if my need is greater than that, then I will go to the power maybe 6. 2s are 4s are 8s are 16, 32, 64. So that will be 64, depending on your requirement. So my requirement is maybe I need 4 networks. If you need more than 4 networks, you can increase this number. Okay, so I did 2, so I'm converting 2. If I did 3, that will be 6. 2 to the 4s are 8. If I did 4, 16. If I did 5, like that. So this is number of subnets is 4. And number of subnets per host, or number of hosts. This is not subnet, sorry, this is number of hosts. So these are the number of networks. And how many hosts I have in per network? So 2 to the power host bit minus 2. So what is the host bit? 6. 2 to the power 6 minus 2. 2 to the 4 are 8 to the 16, 32, 64 minus 2 is 62. Now I know I need 4 networks and I need 62 in each network. So this is my requirement. This is step 1. This is step 2. So third step is block size. So you should subtract this from 256 to get the block size. So always subtract this value. So this I call CSM, customized subnet mask. This is not default subnet mask, but default subnet mask is this one. So this, what I got right now is CSM, customized subnet mask. So if you see a subnet mask like this, that means subnetting is done on that network. Now, block size is 64. So what I do start with 0 plus 64 plus 64 gives 128 plus 64 gives 192 plus 64 gives 256. So I need to add the block size and go till 256. Now it starts with 0, this starts with 64, this starts with 122, 8, this starts with 192, this starts with 256. So this starts with 0, it is going to end with 63 because next is starting with 64, so this will end with 63. So this is going to start 128, so that means it's going to end 127, then only you can get 128. So the series goes like this, so 0 till 63, then 64, 127, then 128, 192. Sorry, this is going to be 191, correct? This has to be 191. This will be then 190. Okay, because this is 192, it has to be one less. Okay, 191, 192, then till 225. Okay, so then we don't need this because we are reaching up to 255. Now what we got 4 subnets. So 1, 2, 3, 4. And each subnet will have 1 till 62. So 1 till 62 means how many hosts? 62. Because 1 till 5 is 5. 1, 2, 3, 4, 5. 1 till 2 is 2. So 1 till 62 is 62. So we will have 62 in each subnet. So that means we are designing it properly. So this is how we can check. So I have designed 4 networks. In each network, I have 62 hosts. And if I, compare that with this example now, so I got it like, if I take the first subnet, so it is going to start with 192.168.3. You replace that last bit with 0. And the first is going to be 192.168.3. You replace this one, this is going to be 1. Okay, so series will go till 192.168.3. This is going to be 62. And the last is 192.168.3.63. So this is going to be your network ID. And this is going to be the last one is going to be your broadcast ID. So network ID in the sense, if I need to send a packet from 5.network, that has to go someone in this, like, 3.5. So 3.5 is in 3.0 network. So routers will send this to the 3.0 network. So this will be, this is to understand that the packet should go to this network. Like, for example, you are sending a packet to someone in UK. So you have to give it to the UK router. So it will, you need to identify which router it should go to. So that's going to represent the network ID. Which network should it go to? So it goes to 3.0 network. And the 3.0 network is going to give to a switch. Switch is going to locate where 2.5 is. So switches care about the hosts and routers care about the network and the best way to reach. So that's where you have the network ID. And broadcast IDs, if you want to send a broadcast to all these in this group, then you can use this last IP to send a broadcast to everyone in that particular group, right? So that's why every group will have one network ID and broadcast ID. So I'll come up with some other video where we're going to see how we implement it, but this is the simplest way of subnetting. So you might have seen a lot of other techniques of subnetting, but this is the best way to do subnetting. So you start with class C. Most of the times, we go with class B, then we go with class A. But once you master class C, then there's one concept which we call subnetting in head. So if you understand this concept in detail, how to do subnetting with this example. First, define your requirement. How many number of first take the subnet mask and define your requirement. Convert those zeros into ones. Then how many subnets you have, how many hosts in each subnet. Start designing it, and then these are the steps to do subnetting. So once you master this, then in exam related to anything, like network plus or CCNA, they will ask you subnetting in head. Now they will give you the requirement, how many networks I need, how many hosts are there in a network, if this is the number of subnets and all that. But this is the simple way. First, follow this technique, and then I'm going to come up with some other video where we'll see how we design it, how we implement it. So please like, subscribe, share, and keep supporting so that I'll come up with some important concepts in networking. So I'm making these things very simple so that, once you master the network basics, then it will be easy for you to understand other things. So thank you. See you maybe in some other video.